Guys, Mr. Bowman here. Today's learning objective is in blue, and we are learning to use trigonometry. That word's going to be new to most of us, to calculate the sides of right angle triangles. So hopefully from the previous video, you've got a good understanding of what right angle triangles are. And hopefully in today's video, you're going to develop an understanding of trigonometry and how we can go ahead and use it to solve for these sides. So before we start, I'm just going to run through the 4 steps you need to do to use trigonometry to find the sides of a triangle. So step 1, you must label the sides of your triangle. So label sides of triangle. I'm going to go ahead and explain each of these points in a lot more detail, but I just want to outline them initially before we get going. Step number 2, you must identify the formula that you're going to use. So just going to note there are 3 formulas, and we need to know when each one is relevant. Step 3, something we've looked at before. You now need to go ahead to substitute. And then step 4, another S word we're familiar with, we then go ahead and solve. Let's jump straight into that first step that we're given here. And I'm going to move over a little bit, and I'm going to draw a random right angle triangle. So you'll see a lot of them will look like this in our work. So here's our right angle triangle, and I'm just going to make up that we know what this angle here is. Let's say that there is 40 degrees. There are 2 features we need to know. We're always going to be given the right angle, and normally you're told another angle, and I call this the given angle. And that's because we're given it, and that last angle there, we're not given that. There's no information there, so we don't really use that information or that triangle or that angle for our work. So let's change pen colors. Based on those angles there, we need to know when is something the hypotenuse, so the hypotenuse, and then use when is something the adjacent, and when is something the opposite. I normally identify the hypotenuse first, the opposite second, and then the adjacent third, but we need to know each of those. So the hypotenuse is always opposite the right angle. So I should have left my room, but that's opposite the right angle. The opposite is now what we're referring to. We're going to find the given angle, and we're going to go across. And that there is opposite the given angle. And the last one, the adjacent, it's normally the leftover side. Oh, I just realized I forgot to write an O for opposite. The last one is normally sitting between the given angle and the right angle. This is normally just the leftover one, so it's easy to identify, but formally it's between the right angle and the given angle. So hopefully that makes sense. Hopefully that gives you enough information to label the sides of a triangle. Let's quickly draw another one. So there's our right angle triangle. Let's say we're given this angle down at the bottom. So find the right angle. The opposite to that is the hypotenuse. Find the given angle, or the angle you're using. The opposite to that is the opposite. And between the right angle and the given angle is the adjacent. So hopefully that recaps that. Hopefully you've got a good understanding of how to label the hypotenuse, the opposite, and the adjacent. I'm now going to clear my screen. We've looked at the first step. We're now going to figure out, or how can I use this information to identify the formula that we're looking into. Okay, so we're now looking at the formula, and there are 3 formulas that we need to know about. So 3 formulas that we need to know. And a common abbreviation that people use to remember the formulas is SO, CA, TOA. And you'll notice the last two letters of each of them, OH, that refers to the opposite and the hypotenuse. You've then got AH, which refers to the adjacent and the hypotenuse. And then you've got the OA, which refers to the opposite and the adjacent. So depending on the sides of the triangle you've got, that's what formula that you're going to use. And the formula is always going to be sine angle equals opposite over adjacent. The car one is going to be cos angle equals adjacent over hypotenuse. And then the last one, TOA, tan angle equals the opposite over adjacent. So at this stage here, I suggest you pause the video and have a look on your calculator for buttons that say sine, cos, and tan, because those buttons on your calculator are going to be really, really important for helping us solve these types of questions. And I've got three white photos on the screen that you've seen popped up. And in those photos, there are three triangles, and we're going to go through how to find the relevant formula for each of those triangles. And for each of them, what you'll see is the right angle is given to us in all of them, and we didn't have it here, but there it is. We can see they've all got a given angle. They've all got a side that we know, and they've all got an unknown side. So we're trying to calculate those unknown sides of those triangles. So we'll get rid of all that. So first step for your triangle, we're going to look at this first one down on the bottom left by Meowth. We're going to be labeling the sides, the hypotenuse, the opposite, then the adjacent. So we find the opposite. So there's the right angle. We go opposite, which means the side we're trying to find, that H, is across there on the diagonal. Here's the given angle. We go to the opposite, which means that side there is going to be opposite. And the one between the right angle and the given angle, that there is the adjacent. Now, when you look at your triangle, you can see the unknown side and the side we know about. Those are the two letters that determine what formula we're going to use. Notice the O over here. We don't know the side, and we don't care about the side because we're not asked to solve it. So we don't care about this side of the triangle. So A and H, we then go up to our formulas up here. And A and H, you'll have a look, that's the cos formula. So it's car, AH. So that means the formula we're going to use over here is cos angle equals A over H. We'll go ahead and finish off that equation for step 3 and step 4. But we'll leave that there for now because we've identified the formula, and that's what we're trying to do for this particular discussion point. Middle triangle, we're going to do the same thing. Here's the right angle. Opposite to that is the hypotenuse. So there's our H value. There's our given angle. Opposite to that is the opposite. And between those two is the adjacent. We now need to think which side don't we care about? We don't care about the A there. But we do care about the O and the H. So based on O and H, we're going to be using the soft formula because the O and the H are after that. So let's write down our formula below. So sine angle equals O over H. And again, we're going to leave that. We'll move on to the next triangle. The right angle is down the bottom corner here. Opposite to that is the hypotenuse. Here's the given angle. Opposite to that is the opposite. And between those given angles and right angles is the adjacent. We now cross out the side we don't care about. In this case, we don't care about that hypotenuse. We're not asked to solve for it, and we don't know it, so it's gone. That leaves us with the O and the A. That's the TOA, or the OA part of TOA. So that means that side there is going to be using the tan formula. So let's write that formula up here. So tan angle equals O over A. So hopefully you can see how you can identify each of the formulas that are relevant. Cross out the side and then figure out what two letters are in that SACA TOA that you're looking for. So I'm now going to pause the video. I'm going to get rid of some other stuff, and we're going to have a look at the substitute and solve portions of this process. So our screen's looking a bit clearer. We're now going to do steps 3 and 4 kind of at the same time. First step, we're going to substitute. So this delta is what we call it. This delta in the middle, or no, theta, sorry, this theta in the middle, that always refers to the given angle. So delta, or theta, refers to the given angle. So what we're going to do is we're going to substitute the given angle, 43 degrees, where that delta is. So it's going to be cos 43. That there is going to be equal to the adjacent, which is 35. So we're going to substitute that in where that is. So 35 divided by p, because that's what we've noted the hypotenuse is. Once you've substituted it in, you're now going to use your algebra to solve these. So just a reminder, we've got invisible brackets all over the show. So we need to get rid of the divide by p and then go times p. So that means p times cos 43 equals 35. And at this step here, I can't emphasize this enough, but cos 43 is just the number. So that's kind of similar or the same as 3p equals 35. To get rid of that times 3 or that times cos 43, you need to go divided by 3, divided by 3. So we're going to do the same here. We're going to go divided by cos 43 and then divided by cos 43. So that means p will be equal to 35 divided by cos 43. This is where we need our calculators. So we can't do this type of maths in our head, but 35 divided by cos 43, that there is equal to 47.9 meters, and I've rounded that to 1 dp. So really important for trigonometry, always include your units. If you're having issues with calculating that, do grab your teacher, ask your mate. It's important you know how your calculator works, and make sure you're on the degrees setting, which will change your answer. So if you're on something called radians, you'll get a different answer. Okay. So we've done the first one. Hopefully you can see how the substitution and the solving works from that. We're now going to move on to that second triangle in the middle. And we go through our substitution. So down the bottom, that theta, that delta, or whatever I'm calling it by mistake, that there is the given one. That's 60 degrees. So we're going to have sine 60 equals O. We've noted as x. So we're going to put in the x there instead. And the hypotenuse is 32. That's going to be divided by 32. And this algebra here will be a bit easier to solve than the first one, because when the letter's on the top, it's normally a bit easier to solve. We're going to get rid of that divide by 32 by doing times 32. So that means 32 times sine 60 will be equal to x. We then get our trusty calculator to finish that off for us. So 32 times sine 60. That there, hopefully you're getting 27.7. Our units in this case is centimeters, and I've rounded that to 1 decimal point as well. So just a note at this stage, your rounding doesn't matter. If you round it to 2 dp, 3 dp, whatever, that's all good. You'll still get full marks for that. So we now got to our final triangle, and let's go through that process again. So what's the given angle? That's 18 degrees. So let's substitute that in. So we've got tan 18 is equal to O, which we've noted as H. So we're going to put H on the top, and we like that because the algebra is easier when the H is on the top, divided by A, which is 100. We're then going to go solve our algebra by doing times 100 times 100. So that means 100 times tan 18 will be equal to H. And I'm going to flip the H to the other side. H is going to be equal to, grab out your calculator, do it with me, 100 times tan 18. Hopefully you're getting 32.5, in this case meters. And again, state your rounding. I'm rounding to 1 dp over here. So that last step, that purple stuff, that's all the substitution involved. Just a reminder, based on that, we substitute the given angle, the unknown variable, and the measurement into our equation. We then go ahead and use our algebra to solve. But the big thing I want to emphasize, stuff like cos 43, which we used in question 1, sine 60, tan 18, these here are all just numbers. So they look intimidating, but they're just numbers. We can move them around. We can divide in times like our normal algebra. that wraps up our video, guys. Thank you so much for watching. Now let's get into heaps and heaps of practice. Hopefully you saw the Meowth again. He was involved a little bit today. But see you later on, guys.